There are questions that run through the history of humanity like veins of fire beneath the crust of thought. One of them is so powerful, so magnetic, that it has made us lift our gaze to the sky since the dawn of our existence. Are we alone in the universe? It is not just curiosity. It is an ancestral need, an almost biological reflex, as if our very cells, made of the same atoms forged in the hearts of stars, long to speak again with the cosmos. When we look at the night sky, we don't just see bright points, we see possibilities. Each of those lights could be a sun, and around each of those suns, worlds could be orbiting. Worlds with oceans, mountains, winds, perhaps creatures. Perhaps intelligences. And this is no longer just poetry, it is science. Our era is the first in history in which we can truly search for life elsewhere with concrete tools. With the James Webb Space Telescope, launched in 2021, we are analyzing the atmosphere of planets tens of light years away, searching for chemical fingerprints, oxygen, methane, water vapor. Signs of metabolism, of something that breathes, grows, changes. Among the most exciting discoveries of recent years are worlds like TRAPPIST-1e, 40 light-years away, a rocky planet, the right size, in the so-called habitable zone of its system. Or Kepler-442b, 1,200 light-years away, which shows ideal parameters for the presence of liquid water. But the real revolution lies not only in the discovery of habitable worlds, it is in their sheer number. Every star, it seems, has at least one planet. In our galaxy alone, there could be over 100 billion exoplanets. If even just 1% were potentially habitable, we would be talking about 1 billion chances for life, in the Milky Way alone. And the observable universe contains, by cautious estimates, over 2 trillion galaxies. The numbers defy the mind. But the message is clear. Life, statistically, should not be an exception, but a consequence. And yet, as we look up, the sky remains silent. This is the Fermi paradox. If the universe teems with civilizations, where is everybody? The radio waves are silent, no artificial signal has reached us. Some scientists speak of a great filter, an evolutionary barrier that prevents civilizations from surviving long enough to colonize the stars. But we don't know whether this filter lies behind us or ahead of us. Perhaps intelligent life is rare because the universe is hostile. Perhaps it self-extinguishes. Perhaps it exists, but it is too different, too advanced, or too silent. Or perhaps, quite simply, we are not listening in the right way. This is why new approaches are emerging. Modern astrobiology no longer seeks only life like ours. It asks about life forms based on alternative chemistries, extreme environments, evolutionary structures not found on Earth. New research programs are not limited to SETI's radio waves. Today, scientists study advanced technosignatures, such as artificial satellites orbiting distant stars, anomalous light fluctuations, thermal signals compatible with megastructures. But the question is not only whether other life exists. It is also where we will search for it. Our own solar system might hide surprises. Europa, a moon of Jupiter, conceals an underground ocean beneath its icy crust. An environment shielded from radiation, warmed by tidal interactions, potentially similar to Earth's oceanic depths. Enceladus, a moon of Saturn, expels geysers of salty water containing organic molecules. Titan, with its seas of liquid methane, represents a living laboratory of prebiotic chemistry. The next space missions, such as NASA's Europa Clipper and ESA's JUICE, will target these very places, searching for indirect evidence of metabolism. They won't be looking for aliens with antennae, but for amino acids, chemical gradients, unstable isotopes. In short, traces of simple life, but life nonetheless. And if we find it, even microbial, even rudimentary, everything will change. Because it would mean that life is not an isolated miracle, but a property of matter. As if the universe, when conditions allow, cannot help but produce life. It would be a revolution comparable only to the discovery that Earth is not the center of the cosmos. But if looking outward is fascinating, looking forward is even more so. The future of space exploration is not made only of probes and telescopes, it is made of human bodies walking on new worlds. And this reality is closer than we think. The moon will be the first step. After decades of waiting, humanity is preparing to return to our natural satellite. Not to plant flags, but to build outposts. Artemis 3, scheduled for 2027, will bring humans to the lunar South Pole, where permanently shadowed craters may contain water ice. That ice can be turned into oxygen and hydrogen, air to breathe, rocket fuel. In other words, the moon will become a cosmic gas station. But the true dream is Mars. The red planet exerts an almost mythological pull, desert, mysterious, once brushed by rivers and oceans, with a thin carbon dioxide atmosphere and extreme temperatures. It is the ideal candidate for the first human colony. Not because it is welcoming, but because it is possible. Projects like SpaceX's Starship aim to make travel to Mars a reality within the next 2 decades. It will not be a vacation. The first missions will require survival in sealed habitats, hydroponic farming, and the use of local resources. But in time, if we overcome biological and technological limits, we could see the birth of a second cradle for humanity. Some scientists already speak of terraforming, the idea of altering Mars's atmosphere to make it more like Earth's. It is a colossal undertaking, one that would take centuries or millennia and immense amounts of energy. But it is not a utopia. It is a theoretical option seriously discussed in astrobiology and planetary engineering. Meanwhile, new technologies are revolutionizing space propulsion. Chemical rockets, though effective, are slow and limited. Ion and plasma engines are already flying on robotic missions. But in the future, we could see boulder systems, solar sails harnessing sunlight for propulsion, or miniature nuclear reactors shortening travel times. Even nuclear fusion, the energy of the stars, is being studied as a way to generate thrust in deep space. And then there are interstellar missions. For now, only 2 human-made objects have left the solar system, Voyager 1 and 2, launched in 1977. But the breakthrough Starshot project dreams of sending tiny vehicles to Proxima Centauri, the nearest star, 4.2 light-years away, at speeds close to 20% the speed of light. At such rates, we could reach other star systems in decades, not millennia. This brings us to another fundamental question. Why should we explore space? It is not just about science. It is about survival, curiosity, expansion. Our planet is fragile. Between wars, climate change, asteroid impacts, epidemics, and geopolitical instability, the idea of putting eggs in more than one basket is not just intriguing, it is prudent. Every species that has dominated an ecosystem has eventually faced a crisis. We might be the first species capable of escaping that fate. But space exploration also has a philosophical value. It forces us to confront who we are. To reflect on what it means to be human in a vast, silent universe, perhaps populated, perhaps not. If one day we find life on another planet, even just a microbe, we will understand that life is a cosmic phenomenon. If instead we find nothing, we will be the unique bearers of consciousness. In either case, the responsibility is immense. There is also another horizon. The future of non-terrestrial life might not be biological at all. Artificial intelligences, synthetic life forms, digital minds may one day explore space better than we can, surpassing the limits of flesh and time. We could send copies of our consciousness aboard interstellar probes, colonizing the cosmos with mind if not with body. But the deepest beauty is that all this is not science fiction. It is science in motion. It is technology in development. It is desire in evolution. We are entering an age in which the question, "Are we alone?" will no longer be an eternal mystery, but an inquiry pursued with instruments, data, experiments. In which the idea of walking on other worlds, of finding fossils on an icy moon, of intercepting a transmission from a distant civilization, will no longer be legend, but possibility. And in the end, perhaps the true revolution will be this: not finding other living beings, but rediscovering ourselves. Understanding that humanity, in its fragility and its courage, is capable of crossing the void between stars, not to conquer, but to comprehend. To listen. To become part of a cosmos that, after billions of years, has finally found a voice. Ours. If you've made it this far, it means you love curiosity as much as we do. If you enjoyed this journey, leave a like, write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence truly makes a difference. Until the next exploration.